Okay, so when we were in the lab a couple weeks ago, we made an electromagnet, correct?
Yeah.
And what are the parts of our electromagnet? What are the parts, what are the pieces of our electromagnet? What's one piece? Copper wire. Oh, wrong color. We had the copper wire. What was another piece, Carolina? The battery. And what is the last piece, Nathan? The what? The nail. Alright? Now, the special thing about this nail is it has to have an iron core. And why do you think it has to be iron, Stephanie?
Because iron is like this metal that is okay, but it's not the best, it's not the worst. So it won't conduct a lot of energy, like it will get hot super fast, it will get hot.
Okay. Iron is not the best metal, but it's not the worst metal. Okay. So what is it we know about iron and magnets?
Magnets are attracted to iron.
What?
Magnets are attracted to
Iron is attracted to a magnet. All right? And that's really the only, as far as you're concerned in 4th grade, iron is the only metal that's attracted to a magnet. Make sense? So the reason that steel is attracted to a magnet is because you remember steel is a metal, is a mixture of metals. You remember talking about that when we talked about magnetism? So our paper clips are made of steel, which has iron in it, which then makes the paper clip magnetic, right? Does everybody remember that from magnetism? Okay. So our nail has to have an iron core in it.
That's what I forgot to put in.
A nail?
Alright, so as we were in the lab doing the magnet, what did we learn about an electromagnet? What is one of the things we figured out about an electromagnet? Here.
You can turn it off and on.
An electromagnet can be turned off and on. So an electromagnet is made from what?
Iron.
Electricity, right? So therefore an electromagnet can be turned on and off. Okay?
Like we watched on that video.
Correct, like we watched on the Brave Little Toaster. Remember the orange guy picking up the cars?
And killing them.
And killing the cars, yes.
Give him a new life. A better new life.
Okay.
It's like that movie about robots. You know, with those machines.
iRobot or something like that.
I can't remember the name with those robots versus the other robots.
I don't remember the name either.
I don't remember a.
Well, when I was in college, over the summers I worked in a warehouse, and one of the things I got to do was on the trucks.
Mhm.
And we worked building pipelines or building metal stuff. And I got to work with an electromagnet contextual overhead crane. It could lift up to 2,000 pounds. And it just had this handle, and you switch it on, pull on.
Right.
Electricity flowed through it, and it picked stuff up. But you had to be careful because it would suck up your keys or whatever. If you have the
Or
right.
your iPhone.
Right.
No, that's not right. But then when you use the crane, move it someplace you want it, and then you just turn the handle on, the electricity turn on, and then the metal will fall.
So like the size of a truck, it would pick up 2,000 pounds?
A small truck.
Yeah.
But
Well, my truck is 1,500 pounds.
it can tow.
Ah, okay. Cool.
Oh, what if someone's
All right, so and then, so we learned that we could turn our electromagnet on and off. Okay. What else did we learn about the electromagnet?
that it can turn on and off?
The more coils we had on it, the number of paper clips increased. So the more coils I wrapped around it, what is a word I could use for that?
Greater? Increase? Stronger?
The increase, stronger, greater. What?
Energy was flowing.
The more energy was flowing, so the greater the
Magnet. The greater the electricity.
the greater the magnet was, right? The greater the magnetism, the more coils I had, the greater the magnetism I got, right? Does everybody remember that part? Okay. So my copper wire is where the electrons flow. Remember? Electrons, the little negative mark? Where the electrons flow. Where the electrons flow. And when they are increased, what else increases?
The number of paper clips. The metal, the flowing of the magnet.
What is happening in this nail? The more coils. So the more.
Coils.
I already have more coils.
More energy.
More energy flows. So the more
The electricity. Magnetism.
magnetism. The stronger the magnetism. Okay? The stronger the magnetism. You think that's the only way I can increase the magnetism of an electromagnet?
Nah.
Probably not, right?
Maybe a better.
Okay. What does my battery do in an electromagnet?
Gives energy. It's a source of energy.
Okay.
It's a conductor.
So it's the source of energy.
She's recording us. Don't judge me.
And now I should stop.
You just messed it up.
So the source of energy comes from my battery, and I flow from negative to positive, right? Okay. So how do you think how would I have to change the battery to increase the magnetism? What would I have to do to the battery?
We were like doing the like, not really charge it, but like you can charge batteries. Or something like the source. You have to do something like have all the energy attack it like so it gets to the negative to get to the positive faster.
Okay. Can I make a D-size battery any bigger than a D-size battery?
No.
Okay. Is there another type of battery that's got more energy than a D-size battery?
Probably yes.
There probably are, right? So, what could I do to the battery to increase the energy? Change it to a stronger battery. So, add another battery. Actually, kind of a. Add another battery. Or a. Add another battery or a stronger battery. Or a stronger battery. Add another battery or a stronger battery. And what about the nail? Can I change the strength of my electromagnet with a nail?
You can make it bigger to route more coils.
You put more coils.
But that's not the nail. Oh, you can make it bigger to pick up more.
I can make it bigger. Or what else could I add?
What coils?
I can add more
Coils. No, the coils not iron.
iron. Okay, so
Because the
I
coils
can-
are not for the nail. Is that why?
have more of an iron core, or a bigger nail. To increase magnetism.
This is a lot of
Okay, so electromagnets can be turned on and off because they are run off of electricity. All right. The pieces of an electromagnet, I have an energy source, and in our case was a battery, a nail, but I have to have a iron core. Okay. And then the last piece is my copper wire. All right. Now, I can increase the strength of an electromagnet by getting a bigger or stronger battery. More copper wire. Is it really the more copper wire or the more coils? The copper wire. The more coils that copper wire can make. Because what's flowing through this?
energy. Electrons.
Electrons. Because they are a negative charge, they are making this nail a... What are they turning this nail into? A magnet. Okay? So the more negative energy I can get running through these coils on this battery, the more magnetism I'm going to have. Does that make sense? It will get stronger and stronger the more magnetism, the more negative energy I have flowing through the wire. Right?